Good morning, students. Myself, Janish Shah, Assistant Professor at LG Institute of Engineering and Technology. In our previous lecture, we studied about that how can we insert values in circular queue and how can we delete the values from the circular queue. Okay, so at that time we have seen two different algorithms for the insertion in circular queue and for the deletion from the circular queue. Okay, now let's see the example that how in exam you have asked for the questions. Okay, so here I have one example that show the position of F and R. F means front pointer, R means rear pointer. So here the example says that shows the position of front and rear in circular queue of size 6. Okay, assume F at 2 and R at 4. Q is equal to blank L M N blank blank. Okay, fine. So let me first explain the what do you mean by this example problem. Okay, so here students, here front pointer is position is already given at 2, rear pointer position at 4. Okay, now according to this figure, okay, let's assume that how the front and rear will be pointed to the elements. Okay, so see, here we have L and here we have N. That means front pointer should pointing to the first element of the queue, that is L, and rear pointer should pointing to the last inserted element of the queue, which is N. Okay, okay, fine. So here R should be here and F should be here. So if you have seen that here front pointer position is 2. Okay, so it means if we consider this is as 1, then it will become 2. That means our indexes starts from 1. Okay, if you somehow if you have any problem that sir when the indexes will be started, then in exam you should write it down or you can calculate by this problem that the where is the F position. Here F position at 2 and R position at 4. So we can say that that the array index starts from 1. Okay, fine. So let's begin. Here size is equal to circular queue of size 6. That means size is equal to 6. So we have 6 element size queue where right now front pointer pointing to L, that means second position, and rear pointer is pointing to 4, that means N. Okay, so now here the array index starts at 1. So let's begin to calculate F and R. Here we in a problem we have given different type of operations applied on the queue. The same questions can be asked for the simple queue, but I am just taking an example for the circular so you can directly connect it with the simple queue. Okay, fine. So let's begin. See, this is the chart or this is the number of operations that we need to perform. If in exam you ask such questions, you just need to draw the operation. Okay, then beside that write F. F shows the position of the front pointer, R shows the position of the rear pointer, and then write Q, where the Q shows the elements inside the queue. Okay, so if this is my first position, that at the beginning my front pointer pointing to 2 and rear pointer pointing to at 4 index. Okay, so here is my front at L, rear is at N. Okay, so what is the next operation? Okay, what we need to do? Add O. Students, tell me, in Q insertion occurs at rear end. Again I am repeating the same statements which I have said earlier in my last session, that Q insertion will be occurred at rear end and Q deletion will be occurred at front end. Okay, on the other hand I can say that rear is used for the insertion and front is used for the deletion inside the queue, whether it is circular queue or simpler queue. Fine. So here, as you know, we need to add something in the queue. That means it will be added at the rear end, so it will be added after N. Okay, after N. Okay, so rear pointer is incremented. Rear pointer is incremented from 4 to 5. So front pointer is as it is. The position of the front pointer will never change. Okay, in this condition, and we just need to increment rear pointer Okay, so it becomes 5, and I need to add a O. See, O has been added inside the queue. Okay, so now let's move forward to the next thing, that is add P. Okay, again I need to add something. Students, just check whether there are space or not in circular queue. Yes, still one space is left. One space is left. So I can add more elements over there. So if I need to add again, front pointer is incremented or rear? Just tell me, front pointer is incremented or rear pointer? It's rear pointer incrementer, because in queue insertion will be occurred at rear end. Okay, so here I'm just incrementing rear pointer and remain front pointer as it is. It is at 2, rear should be 6, and it is inserted inside the queue P. Okay, now I want to delete something. When I want to delete something, what I need to move? I need to concern about only front pointer. I should not know that where is the position of rear pointer right now. Okay, what is the position of front? It is incremented in that. Okay, so the after deletion, front pointer will be incremented and go to the next element. So right now the front pointer pointing to L at position 2. So front pointer position will be changed and becomes 3. Okay, rear as it is. One again blank space occurred. L is deleted. See, L is deleted from the queue. Okay. Now we have another deletion operation. I want to perform another deletion operation. So what you need to do? Just increment front. It becomes 4. Rear at 6, and M is deleted from the queue. Got it? Now see, I am adding 2 elements simultaneously, but it has never happened. You can insert one element at a time, but in operation I just given that just add Q and R to reduce number of steps. Just because of my screen size, I am just adding 2 elements together. First I am going to add Q and then R. So both times rear pointer will be incremented. Both times rear pointer will be incremented. Right now rear pointing to N. See, size of element is 6. Size of element is 6. Rear pointer is again at 6. See, size of element is 6. Rear pointer is again at 6. So R is equal to N. R is equal to N. Check the circular queue insertion algorithm in your notebook. If you have, check the circular queue insertion algorithm or watch my previous video. Okay, so here R pointing to N. That means what you need to do, you just need to increment position of rear pointer. Okay, so what I'm doing, I'm just increment position of my rear pointer. It becomes at 1, because after 6 it is not incremented to 7. 6 is the size, so just put rear at 1. Okay, so rear will become over here. See the mouse pointer. Okay, rear will become over here at 1, and then assign Q. Okay, so Q will be inserted over here. Again I'm doing insertion operation for the R. Again rear is now at 1. The rear is just incremented at 2. So here 2 position incremented by rear and becomes 2. 1 and 2. Okay, front remains as it is. Okay, and when the Q is Q and R. Say rear pointer pointing to be here. Okay, rear pointer is pointing to way here. Okay, next add S. Okay, so how I need to add S? Okay, to add S, what I need to do, just increment the rear pointer. Okay, I'm just incrementing the rear pointer, and it goes like this. Front pointer position as it is, rear will becomes 3. Okay, and S will be added over here. See, okay, fine. Is that clear? So again I need to add T. Students, just tell me the position of the rear pointer. Rear pointer position is 3. Position of front pointer position is 4. Okay, now check the algorithm. I am tracing the algorithm one by one. Okay, what I need to do first, I just need to check whether R is equal to N. Is that so? No. So move R arrow R plus 1. Just increment the rear pointer. Okay, rear becomes 4. Rear becomes 4. As right now rear is 3. Rear becomes 4 according to algorithm. Fine. Now step number 2. Check whether F and R both same or not. See, rear becomes 4. F is already 4. Both are same. That means Q is full. So here, as Q is full, we should not enter or we could not insert anything. So front and rear both are same. So I'm not able to insert anything. Is that clear? Now rear pointer is again set to its previous position. If I want to delete something from the queue, okay, so see, here is the rear, here is the front, okay, here is the rear, here is the front. If I want to delete something, N will be deleted. So increment of front. Now my latest queue is QRS blank OP. Fine, okay. And then my next is, again I want to delete something from the queue. It will become 6, 3, okay. So F pointer will be incremented, again 2 blank spaces are there. Again 2 blank spaces are there. And my last answer is QRS blank blank P. So what is the, after performing each and every operation, I am just showing the position of F and R with the Q position or Q drawing. Okay, with the figure of Q or the elements of Q, I'm just showing position of F and R after performing each and every operation on the circular Q. With this, you can learn how you can show in exam that how the circular key works. Okay, so we just remember the just fast review circular queue. Circular queue insertion deletion we have seen. We have seen the example of circular queue operations. Circular queue insertion done at rear end and deletion done at the front end. Again, if your deletion or if your front or rear pointer reaches at the last position of the queue, you just move that front and rear pointer to the back to the first position. Okay, such like this we can go further. Okay, so right now we just need to move to the next topic, which is double-ended queue. So students, the topic is double-ended queue, and in this topic we will learn about DEQUEue, insertion in DEQUEue. The DEQUEue, that means where you can insert in the queue from the both end, from the front end and from the rear end. Okay, is that possible? Yes, it is possible in DEQUEue. Okay, double-ended queue, where you can perform insertion from the front end and both end. You can also perform deletion from the front end and the rear end. Okay, so insertion and deletion occurs at the both end of the queue. That topic is known as DEQUEue, but that queue is known as DEQUEue. So here we know that how can we insert at rear end, but we will see that how can we insert at front end. So the first algorithm is insertion at front end, then insertion at rear end, and again we'll see deletion at front end, and last one is deletion at rear end. Okay. Example, as we have seen just recently, circular queue example, show the position of front and rear in circular queue. Same like that, we will see another example that show the position of front and rear in DEQUEue. And the last topic is priority. Okay, so let's begin with DEQUEue. So students, DEQUEue is known as where the generalized form of queue where data can be allowed for the insertion and deletion from the both end of the queue. If this is my queue, just imagine if this is my queue, then I can insert elements from the front end, even I can insert elements from the rear end. Okay, got it. So next is two types of DEQUEUs are there. The first one is input restricted DEQUEue. Okay, what do you mean by input restricted DEQUEue? And our second one is a output restricted DEQUEue. So see, this is my DEQUEue. Just wait for a minute. Let me. Okay, fine. See, this is DEQUEue, where insertion occurs at front end, deletion occurs at front end. Again, insertion occurs at front end, deletion occurs at front end. Okay, fine. So insertion occurs at front end, deletion occurs at rear end. Okay, insertion occurs at front end, deletion occurs at rear end. So insertion and deletion both occurs at front and rear both, and that thing is known as DEQUEue. And in input restricted DEQUEue, see, in input restricted DEQUEue, insertion is not allowed at one end. Okay, at any one end, insertion is not allowed. So see, I'm just cut down the insertion from the here. From here, you can insert, you can delete from this end also. Again, in output restricted DEQUEue, you can insert, but you cannot delete from this end. Okay, so anything one is stopped. Okay, so you cannot delete it from this end. Okay, you can delete from this end, you can insert from this end. So insert in input restricted DEQUEue, insertion will not be occurred at one end. From this end you can also do insertion. See, insertion is written over here, but direction is not shown. But okay, but you have to show in this figure that insertion arrow from inside the queue. Okay, so insertion is occurred at this end, deletion is also occurred at this end, but at front end insertion is not occurred. Here deletion is not occurred at front end, insertion has occurred. Here deletion and insertion both occurs at rear end. Okay, so these two queues are known as types of DEQUEue: input restricted DEQUEue, where insertion is not allowed at one end. In output restricted DEQUEue, deletion is not allowed at one end. Okay, so let's begin with the first DEQUEue. Students, in DEQUEue in algorithm, array index starts from 1. Do not forget that. Okay, so here we have 4 algorithms. First, insertion at both end, front and rear, and second one is deletion at both end, front and rear. 4 algorithms are here. Insertion at rear end. First, tell me, in simple queue, we are inserting something. Okay, we are insertion at which end? We are inserting something at which end? That is rear end. Fine. Same like that, students. Here, insertion occurs at the rear end, same as simple queue. Again, insertion occurs at front end. Next is deletion occurs at rear end, which is new for us, and deletion occurs at front end, which is same as simple queue deletion. So, the first algorithm is insertion at rear end. Now, you tell me, then I'll show the steps. Okay, the first step for the insertion in simple queue, just remembering that. Okay, what is the first step? Whether the queue is full or not. Whether the queue is full or not. That means check overflow condition. If, okay, to do any type of insertion, we are taking rear end. No, wait, this is insertion at rear end. Insertion at rear end. So I am concerning with only rear end. Okay, so if my rear pointer is pointing to n, if my rear pointer is pointing to last position of the queue, n, then my queue is full. So this is my step number 1. Okay, if my rear pointer is return equal to n, then write overflow and return. Again, I am saying that return is only statement. We are not returning anything. That's why in algorithm it's procedure, and algorithm name is INS at rear end. Okay, see, my algorithm name is meaningful, that insert at rear end, front, rear, queue, and y. I'm just taking 5 elements over here. Okay, so see, the next is increment of rear pointer. Increment of rear pointer. I'm just incrementing rear pointer, r arrow r plus 1. Again, the next step is assign the new element to queue. Okay, so y is the new element which I need to assign to the rear end of the queue. So q of r is equal to y. Okay, q of r is equal to y. See, I'm just incrementing this pointer. This is my queue, this is front, this is rear. Okay, and the last element to set the front pointer. If my set front pointer is at 0, okay, then just take it more towards the 1. So this is the first algorithm of insertion at rear end in simple queue. It is same as simple queue. This is DEQUEue. Do not forget, this is DEQUEue. Okay. The next is insertion at front end. Insertion at front end. Okay. So how it occurs? See the example. Here we have the procedure INS at the red front end. Procedure INS at the red front end. Okay, we just need to insert something. I'm taking F, R, Q, Y. I'm not gonna taking N, Y. We will see it later. Okay, because the front position of the queue, if this is my queue, this is your front. Okay, at 1. You are decrementing front pointer to insert the elements inside the queue. Okay, because in normal queue, the insertion occurs in this direction. Okay, fine. But here insertion occurs at the opposite direction. Okay, at the time you are just incrementing rear pointer, here you need to decrement your front pointer. Okay, see how. See, the first condition should be see, check the overflow. When my queue becomes overflow according to front. See, one element is there in the queue. If one element is there in the queue, then my front pointer pointing to the first position of the queue. See, if this is my first position, now front pointer pointing over here. If I want to insert something at front end, then I should decrement front. Is there any possibility that I can decrement front pointer? No. Now, can I insert something in this queue? No, never. Please don't say that sir, these element space are empty. Okay, please don't say, because in this direction you can insert elements only and only if there is a rear end insertion. Right now here we need to insert from the front end. That means you need to decrement your front pointer, decrement your front pointer. That's why the overflow condition should be f is equal to 1, then write overflow. Else just see how. This is my f. This is my f. Can I insert anything over the front position? No, because my queue is full. See, if I want to insert over here, this is my rear end, and if I want to insert over here, then I should increment rear pointer. But this is the algorithm for the insertion at front end. This is the algorithm for insertion at front end. That means you should not insert over here. You need to decrement your front pointer, and there is no space to decrement the front pointer. That means my queue is over. Second step is, if f is equal to 0, then move f arrow r arrow 1. Suppose my queue is empty, students. Suppose my queue is empty, then I should move f and r both to 1 and insert the values. Otherwise, what I need to do is f arrow f minus 1. Okay, fine. So I need to decrement my front pointer over here. Okay, fine. So see, what is the last step? What is the last step? See, you just need to assign the value. You just need to assign the value. So just do q of f is equal to 5. So why we are not taking r over here? Because it's an insertion at front end. If the question comes in your mind, so why we are not considering rear pointer for the insertion? Because it's an insertion at front end. Okay, this is DEQUEue. This is not a simple queue. This is DEQUEue where you need to insert at front end. That means you need to concern only about front pointer. Okay, so now let's begin how the insertion will occur at front end. See, this is my empty queue. This is my empty queue where front and rear both are pointing to 0. Okay, now I'm now gonna insert 30. Okay, see, directly inserted 30 over here. This is a situation. Please do not consider both things. Okay, just consider this only. I am taking one scenario that at the beginning point my queue is like this. Okay, now I want to insert something at the front end. So what I need to do, I just insert 20 at the front end. Okay, so my front pointer will be moved towards the next position or previous position according to you. So it points to 2. It points to 2. That means you need to decrement. So according to algorithm, now check the, we're gonna trace the algorithm. Now check the first condition. Check the first condition, whether the front pointer is at 1 or not. Front pointer is at 1? No, never. So you can move forward. Now check, front pointer is at 0. No, front pointer is not at 0. Front pointer is at 3. Okay, so just move. What you need to do, you need to decrement your front pointer. Okay, I'm just decrementing my front pointer and then assign the value 20 over here. Got it? See, insertion will be occurring in this direction. See, I will see insertion is occurring opposite direction, like 30, then 20. Okay, now wait, then the next is insert 10. Insert 10. So what you need to do, again you need to decrement the front pointer, again you need to decrement the front pointer, and insertion 10 will be occurred. Now again if I want to insert something, now can I insert over here? No, because the front pointer is pointing to the first position. In DEQUEue, when you are inserting elements at the front end, at the time the front queue becomes overflow if your front pointer pointed to the first position. Fine. So here the queue is full. You cannot insert anything. Okay. So in that today's lecture, we have seen the example of circular queue. How can we move the position of front and rear, or how can we show the position of front and rear when such type of examples asked in your exams. Then we have seen that what do you mean by the DEQUEue, types of DEQUEue, and there are 4 algorithms are there: insertion at rear end, insertion at front end. Both algorithms we have already seen. Insertion is rear end, it is same as simple queue insertion. Insertion is front end, we have just recently seen that where we need to decrement the front pointer and assign the values in queue. Now, in our next lecture, we'll talk about that deletion at rear end and deletion at front end. Then we have seen about the queue application and priority. Till that, if you have any query, then please feel free to ask me. Till next lecture, please keep smiling and keep learning. Thank you so much.